The reason I want to talk about climbing stairs, this specific question, is because I've seen a lot of YouTubers. They've talked about this question, but I don't think they explained it clearly. So I want to talk about my own understanding. I want to share my own opinions about this question. And another reason I want to talk about this question is because although it is categorized as an easy question, I don't think it is that easy. I mean, the data structure and the algorithm itself is easy, but it is very hard to map this question into a valid solution. That is why I want to talk about this question today. So let's get started. So the question is, you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? For example, if you only have one stair, then you only have one way to climb it because you can only take one step further and get to the destination. However, if you have 2 steps, then you will have 2 ways to get to the top. You can take one step at a time and eventually get to the top, or you can take 2 steps at once and get to the top. And if there are 3 steps, then you will have 3 ways to get to the top. You can climb 1 step at a time and eventually get to the top, or you can take 1 step and take 2 steps, or you can take 2 steps and take 1 step. Therefore, you will have 3 ways to get to the top. If we try to identify the pattern in this question, we can find out that, for example, if there are n steps, all the possible ways to get to n steps, assume we've already know all the possible ways to get to n-1 steps and all the possible ways to get to n-2 steps. So now we want to know all the possible ways to get to n steps. And all the possible ways to get to n steps would be equal to all the possible ways to get to n-1 steps plus all the possible ways to get to n-2 steps. And the principle behind this equation is that if you imagine if you've gotten to n-1 steps, there's actually no choice. You can only take 1 step further and get to n steps. So that is why we can add all the possible ways to get to n-1 steps, because you really don't have any choice other than take 1 step further. And if you are in n-2 steps, if you are in this position, you actually have 2 choices. You can take 1 step further and get to n-1 steps, and take 1 step further, get to n steps, or you can take 2 steps at once and directly get to n steps. However, if you come across n-1 steps, then there will be repetition in our final results, because we've already added all the possible ways to get to n-1 steps. So if you step upon n-1 steps, then we've calculated it. So now you are calculating it again, so it's repetition. So we should not across n-1 steps. So the only way for us to have a new way to get to n steps would be take 2 steps at once and directly get to n steps. That is why we can add n-2 steps, because we can have all the possible ways to get to n-2 steps and then take 2 steps and directly get to n steps. And so we can have all the possible ways of n-1 steps plus all the possible ways of n-2 steps. If we are in the position of n-3 steps, then we have several choices. We can take 1 step further and step upon n-2 position, or we can take 2 steps together and get to n-1 steps. However, we cannot take 3 steps together and directly get to n steps. And there is a problem with this, because if we take 1 step further, we will get to n-2 steps. And we've already added all the possible ways to get to n-2 steps. So it's already calculated, it's already in the results, and we cannot add it. because it will be repetition. If you take 2 steps further, same, we'll get to n minus 1 steps. And we've already calculated all the possible ways to get to n minus 1 steps, so it is repetition as well. Therefore, we cannot add n minus 3 steps because it's already in the it's already in the n minus 1 steps and the n minus 2 steps. Instinctively, we will think of the Fibonacci sequence because it just matches so much n minus 1 and n minus 2. However, the problem with this sequence is that the time complexity will be too much because there will be a lot of repetition in this whole sequence. Minus 3, minus 4. Please forgive my terrible penmanship. So there are a lot of repetition. n minus 2, n minus 2, n minus 3, n minus 3. The thing is, we can store those values in an array memorization, and we don't have to calculate all this thing. Actually, it will become linear, and in this situation, the time complexity will be O of n because it's linear, and the space complexity will be O of n as well because array will in this array we will store from the number from 1 all the way to n. However, that's a better solution actually, because if you really think about it, we only have 3 variables, n minus 1 plus n minus 2. We only need 3 variables, one as a result and one as a first element and the second steps, first step and second step, and the third step, which is the result as well. So in this situation, the time complexity won't change, but the space complexity will be O of 1. So let's code this question. First of all, we should define the base. For example, if n is equal to 1, then we should just return 1. If n is equal to 2, then we should just return 2 because for 2 steps, there are 2 ways to do it. And because there are strings, like n must be greater than or equal to 1 and must be less than or equal to 45. So we don't have to consider 0 in this case. And we should define the first value and the second value. The first value would be 1 because it's the first step, and the second step would be 2 because there are 2 ways. And in the third step, we should, and basically next we will get n that is bigger than 2. So for n, so for step in range n plus 1, we should got the third step. Third step is equal to the first step plus the second step. And the first step should be equal to the second step, and the second step should be equal to the third step. And we can just return the third step. Bingo, there we go. So I think that's it, and see you next time.